Hello everyone. Today we will discuss important result of vector space and some questions of vector space. First of all, Rn over R be the vector space, and this type of polynomial also be the vector space, and every field is vector space over its subfield. For example, R over Q be the vector space and C over R be the vector space. As we know that Q be the subfield of R and R be the subfield of C, where R be the real number, C be the complex number, and Q be the rational number. Now some questions are: which one is the vector space? Z over Z be not vector space because inverse property not held in integer number. Z over Q not vector space because Z in Z no inverse property hold. Similarly in ZR and ZC and Q of Z. Now Q over Q be the vector space and Q over R be not vector space because R be the field of Q subfield. So R be the large and Q be the small, so it cannot be vector space. Similarly, Q over C be not vector space and R over Z is not vector space because Z in Z integer not inverse property hold, and R over Q be the vector space and R over R be the vector space. R over C be not vector space because C be the field and R be the subfield, and C will large and R small from C, so it cannot be vector space. C over Z not vector space. Similarly, C over Q be the vector space and C over R be the vector space and C over C be the vector space. Now, which of the following be vector space? Z over Z is vector space. It cannot be, as above discussed. Z over Q be not vector space and Z is vector space over C. It cannot be, as above discussed. So its option are D. Which of the following is true? Q is vector space over Z, as in Z not inverse property hold, so it cannot be vector space, and Q is vector space over Q. It be true. Q over R be not vector space because R is the large and so it cannot be vector space. Q over C also be not vector space because C is also large, and it can also be defined that Q be the subfield and C be the field, and subfield can't contain be the field. Now the next question is: which of the following is true? Z over Z is vector space not. Q is vector space over Z. It can't because Z in Z integer not inverse property hold. R is vector space over Z. Similarly, it can't be vector space, so its option be none of these. Next question is: which is one not vector space? As we discussed, C over C is be vector space and C over R can't C over R be the vector space, as we discussed that Q is contained in R and R is contained in C, so field contains subfield, it can be vector space, and C over Q be the vector space because field contains subfield, so it be true and it be true also. C over Z not vector space because Z not inverse property hold. And next question is: which of these following statement is true? Q is not vector space over R. Q not vector space, it be true. R is not vector space over C, it be true. Not means नहीं है. C is vector space over R, it be true. हाँ है. So all of these. Now we discuss some questions from the BSc mathematics books. C is vector space over C. It true, and it can be proved by definitions of vector space. C over R be the vector space. Q is not vector space over R because Q over R be field and Q be subfield, so it cannot be vector space, and it can be proved by definitions of vector space. R over C is also not vector space. Now all polynomials over R with constant term 0 be the vector space. All polynomial over R with constant term 1 not vector space, and set of whole ordered pair of integer not vector space. All polynomials with positive coefficient, only positive coefficient, not be vector space. Now set of integer x1, x2, x3, x4 belongs to R4 such that x1 equal to 0 be vector space, less than and greater than these are not vector space. X4 equal to 0 it be vector space. X3 square greater than equal to 0 it be vector space, and x1 plus 3x2 equal to 0 it will also be vector space. Next, Rn is vector space over R as we discussed in important results, and it will remember that set of all diagonal matrix over R be vector space with respect to addition and scalar multiplication. It will be the important results to remember for competitive exam. And in this also y equal to 6x, it can also be written as y minus 6x equal to 0. So it have equal to 0, so it can be vector space.